Thanks very much for inviting me to come along, and very interesting to hear what Greg had to say about the safety culture. I'm going to touch on the voodoo that we do at Air New Zealand about safety management, risk management, and hopefully there'll be some learnings from that for your industry. It's quite interesting just listening to the conversation here. I've only just been here for about 10 or 15 minutes or so, and the point being is that if I said to you that there was some question mark about whether or not it was safe to get on an aeroplane to go flying, I'm sure you'd be slightly horrified that there would even be that question mark. The reality is I'm sitting in the back of a room and hearing you people talk about whether or not there's a question mark about food safety in New Zealand. Quite frankly, I'm horrified. That's the perspective. You guys are in the industry and you've got a paradigm about what's good and what's good, and you want to go to great. Let me see if I can help you get from good to great. So I run flight operations and safety in New Zealand, part of the executive. My role is to deliver up safe, sustainable and exceptional customer journeys. I look after sustainability in the environment as well. For Air New Zealand, it's part of my gig. Some of you may have been at our launch breakfast just recently. The upshot of it is that one of the conversations that came out of the interview that I did with Greg was the issue around regulatory framework. I was a bit surprised to hear there was a recent food safety event in New Zealand, and there was a certain level of disconnect, I think, between the regulator and the participant. Can't quite understand that. The aviation industry works very, very deeply with its regulator. The regulator is our friend. The regulator is the organisation that facilitates us being a participant in the industry. The regulator in the civil aviation world controls the entry, the maintenance and the exit of participants out of the system. Their role is also to facilitate aviation to connect communities. So there's a social connection. I'll talk about this in a minute, but also there's a accountability with regard to air commerce. So in other words, making things work from a commercial perspective. So the upshot of it is that this is something that I think you need to consider. So let me tell you a story. So I'm flying my 777. How is it that the aviation system is so safe? Oh, and by the way, it is commoditised as well. So it's taken as a given. We don't talk about safety. Once upon a time, there was a bit of mystique about flying. The reality is that there was a slight nervousness about getting on the aeroplane, that sort of thing. Nowadays, you buy a ticket on your phone, you go to the airport, swipe it at a kiosk, jump in the aeroplane, close your eyes, get a meal, watch a movie, maybe, and then you arrive somewhere else and it just happens. Okay? But fundamentally, we're in the process of opposing the force of gravity. Well, think about it. So, you're sitting in a chair in the sky, and there's something fundamentally complicated about that concept, and it requires a certain amount of effort to make it work properly. So I'm taking off in my 777 going across to, say I'm going from London or correction, let's make it Hong Kong to London. And we used to do that route, never made it bean, and that's why we don't do it anymore, but we used to fly across to London from Hong Kong. So I take off out of Hong Kong, I'm flying a Boeing 777, it's got a device in it called an altimeter. The altimeter measures the weight of the atmosphere above it, and so there, as a consequence of that, what it does is it tells you how high you are, okay? It's calibrated in feet, but when I'm in Chinese airspace, and then later on when I get into Russian airspace, we'll use metres. So I've got to convert the feet to metres using a switch. So there's a calibration device inside there. Metre, of course, 1/10,000th of the distance between the equator and the pole. For those of you who didn't know, that's how it was worked out in the first place. And so therefore, and then later on when I get into European airspace, then we'll go back to feet. I'm using GPS technology. Thank you, Ronald Reagan, for getting his pizzas delivered. So GPS technology was given out of the military and back to the civil community. And so I'm tracking down an airway and very accurately heading in a certain direction. Coming the other way, Ivan's come, he's taken off out of Moscow. And by the way, the flight that we goes from London to Hong Kong to London goes straight over the top of Moscow. All right, anybody here done? Yeah, do you open the window? One of those annoying people that opens the window when everybody's trying to sleep. Look down and you can see the ring road over Moscow. So you go straight over the top of Moscow. Coming the other way, Ivan, He's flying in his Aleutian, right? And he's using a Kalashnikov altimeter made by the Kalashnikov altimeter company of Belarus, in Minsk in Belarus, not actually part of the it's sort of on the outskirts now. And the upshot of it is that his altimeter, which measures the weight of the atmosphere and above it, is calibrated in metres, and he's going to convert those to feet. All right, and I'm going to get into the bunk. I don't know if you know. For those of you in row 2 of the, some of you may sit in the front of the aeroplane. Row 2 is never a good row to be in a 777 because, of course, there's no overhead bin there in the middle. Why is that? Because that's where I am sleeping. I am actually up in that part. That's my bunk up in there, and I'm sleeping the sleep of the innocent, knowing that the aeroplane is sailing through the air, following the GPS signal, heading towards London via Moscow, and Ivan's going to come the other way. And you know what? He's going to pass either above me or below me by 300 metres. It's 1,000 feet apart. Okay? 1,000 feet sounds like a long way. See Auckland's runway? 12,000 feet long. Imagine 12 747s parked side by side. They're 1,000 feet apart. Okay? The length of that runway is the height of Mount Cook, believe it or not. So the upshot of it is that why is it that I sleep the sleep of the innocent, knowing that I'm going to be safe? Well, because the guy who built the altimeter in the Honeywell altimeter in the 777 uses the same book that the Russian guy did in his Aleutian taking off out of Moscow. Back in 1944, there was a hui. It was a hui at the end of the war in Europe, in Chicago, and the nations got together and worked out whether or not aviation was going to be good. So there was the difference between civil aviation and state aviation. And civil aviation, the process of managing civil aviation, was basically codified in Chicago in 1944. It was handed over to a thing called ICAO, which was formed in 1947. ICAO is an organ of the United Nations. So the regulatory framework for the civil aviation system in New Zealand, in Australia, in fact, if you want to be a participant flying in international operations, you have to be a signatory to the convention. And the upshot of it is that it's all controlled by the United Nations. And there's a book for everything. There's a book for the health of a pilot. There's a book for the thickness of a runway. There's a book telling you how to make an altimeter. There's a book for how to produce an outcome when it comes to constructing an aircraft. The rules of the road are all defined in these standards and recommended practices which are used to define the process. So therefore, regulatory frameworks, international regulatory frameworks are good. All right, so that's where the whole thing comes from. New Zealand is a signatory to the ICAO Convention, the Chicago Convention, which is part of ICAO, and then underneath that there of course is the tertiary legislation to produce that. The other regulatory framework that we work in, of course, is WorkSafe. All right, just I touch on it, it's a huge issue for me in Air New Zealand because I look after people safety as well as operational safety, so the WorkSafe team work alongside us to deliver a better outcome for our people. Okay, so just touching on government policy and legislation. In New Zealand, you want to have a look at it? It's worth seeing. New Zealand Aviation State Safety Program. Why don't you grab it and use it to come up with a set of rules with regard to food safety? Because it tells you how to produce a safety management system that's based on risk management. Because safety management systems have to be based on risk. There's no doubt about it. Okay. Air New Zealand is held up in the aviation industry as an organisation that can add a lot of value to safety management system development, not only in New Zealand but also around the world, particularly in the region, the Asia Pacific region as well. So you'll see, if you go to the CAA website, Google SMS, and you'll see Air New Zealand's safety management system there on display. Anybody can borrow with pride. It's one of the things, Christopher Luxon, fake it till you make it, guys. It's one of the things that Air New Zealand does pretty well, actual fact. So borrow it, use it, take it, I don't care. All I'm interested in is making the whole system more safe. Now, what are the key fundamentals? All right, I know I've only got half an hour. I've got to get on an aeroplane at 7:15 to go to Seattle. So I'm just keeping it moving along. Happy to take questions at the end. What are the fundamental issues of a safety management system? So I'm not going to spend a lot of time talking about this. But you need a policy, all right? So it's got to start off with a policy, all right? We will go from good to great by being the best we can at keeping people safe with regard to food. Something like that, okay? You know, then it's got to be done on the basis of risk. Do you think we're absolutely safe flying an aeroplane? No way. Absolutely not. No, wrong answer. Okay? I'm in the business of opposing the force of gravity. Think about it. I'm in the business. Buddy? I'll get to you later. No, we're in the business of opposing the force of gravity, so we cannot be absolutely safe. And I'll tell you what the number is in a minute or two. So we've actually got to manage risk. All right, we've got to understand what's the critical risks and then manage it. It's basic. It's Safety Management Systems 101. So work out what your risk is. From your risk comes your hazards. It's simple. From your risks come your hazards. So you identify your hazards and you manage those. So it's a lot of people worry about this triangle, this pyramid, dealing with this stuff here, which will stop that from happening up to there. That's not the way to deal with it. That's peasant farming.
Your attention, please. The alarm alarms are going to be tested. No action is required. The alarms are tested. No action is required. Thank you.
It's a good thing. I assume there was a safety briefing prior to this conference starting about where we need to go if the fire alarm did go off. All right, I'll carry on. Undoubtedly, I'm going to be interrupted in a moment. So hazard identification and management. And then what you've got to do is set some goals. You've got to set some outcomes. You've got to set some KPIs to deliver the outcomes that you want to achieve a greater level of safety. The next thing, you need a quality assurance program. We have an external and internal quality assurance program. I've got an internal auditing organisation. They're not sort of lurk around green pen kind of guys creating problems for us. Zero finding audits, not worth the paper they're written on. I want outcomes that are going to help me get learnings that are going to make the system better. All right, we do something in the order of 55 internal audits. We segment it, we work out based on risk, and we work out where we're going to target those processes. And one of the biggest thing we do is look for normal behaviour, as opposed to sort of uber behaviour. We want to see normal behaviour, actually analyse that and actually make a difference. So quality assurance program is critical. Included in that is the audits that we get from the regulator. Typically we will be tested by the regulator, I suppose 35 to 40 times a year. They will come in and analyse certain parts of our exposition. I'll talk about that in a minute. They don't test us against the rules. They look at us to say, are we doing it in the way that we said that we were going to do it? All right, because everything's written down in New Zealand. So how I fly the plane, how we will deal with an emergency, how we maintain our aircraft, all of that adds up to a thing called the exposition. So therefore what will happen is the regulator will come in and check to make sure that we actually said we're doing what we said we were going to do. That's compliance versus conformance. The next thing we do is training. The whole thing's got to be scalable, and then it's documented. The documentation is a thing, as I said, called the exposition. It's 244 manuals, believe it or not, that actually, everything from how an aeroplane is loaded, there's things like, do you know what the centre of gravity limit is of an A320? So the aeroplane has to, I've got a centre of gravity. It's a bit lower than it should be. But there is a centre of gravity, all aircraft have a loading envelope, and the centre of gravity has to fall within that envelope. All right, when the passengers and the bags and the fuel and the cargo is loaded on the aircraft, it's got to fall within this range. And it's got to stay within that range during the course of the flight, because the centre of gravity shifts during the course of the flight because we use the fuel. The fuel's in the wings are swept back. As the fuel is consumed, the centre of gravity moves forward generally during the course of the flight. It is for that reason that we ask people to return to their original seats. That's why we do that. So that the centre of gravity has been calculated at the end point of the flight, because when it goes outside or close to the edges of the envelope, the aeroplane becomes more difficult to fly and difficult to handle. It's got nothing to do. I often hear people telling me, oh, that's so we can find you in an accident. No. I might find your teeth, but so what do you think the range is of it? This gentleman over here who's really enjoying this, so what do you think the range is, and how far, 3 inches, 6 inches, 20 inches, 60 inches, what do you think it is?
About 6 foot.
No, 21 inches. That's the range of the centre of gravity on a fully loaded A320, 21 inches, exactly that. All right, that's why it's critical. I've been in an aeroplane and done things that I haven't wanted to do on 3 occasions because of a Game Boy, a cell phone, and a laptop. So, everybody says, oh, it's a myth. Well, if it's a myth, we wouldn't talk to you about it. Why would we make a fuss about it if it was a myth? That's the point, managing safety, managing risk. Okay, moving on. Right, the next thing you have to have, this is critical. I need to make this point, okay? You need to have a just culture. Now, you need to Google it. Dr. James Reason, he's the father of the Swiss cheese. I hate the Swiss cheese because it just keeps being rolled out, okay? The Swiss cheese model. But the key part of James Reason's safety management is about a just culture. And a just culture is one that creates the opportunity for people to tell you what's going on without fear or favour. Okay? It's absolutely critical, and it's why I will resist for a very long time the expectation of the legal fraternity, particularly those who want to sue, because once we go down that path, this is going to dry up. This puts a lot of pressure on it, and will start making it dry up. Okay, but the aviation system, and this is actually in ICAO now. The ICAO rules require. This is not Air New Zealand. This is the aviation system that requires an open reporting culture. So if people make a mistake, what do I do? If people make a mistake, what would I do? I'll console. I will see over here. So these are 3 pillars of the just culture thing. So the first thing about it is there is a system. If there is a system with humans in it, they'll make an error. Okay. I'll give you an example how we try and use technology to take the error out. So pilots do takeoffs. All right. The aeroplane can do a landing. But they don't really do takeoffs at the moment. That'll come. I reckon in 20 years' time, pilots won't be doing takeoffs. They probably won't be doing landings. And half the airplanes that'll be flying around you will be either flown autonomously or will be flown from the ground. So, so think about that. Think about that. And as you know, you probably heard me talking about drones just a couple of weekends ago. Now, the upshot of it is that if there is a system with a human in it, the human will make an error. So what you've got to do is make the system intolerant to human error. Okay, it's as simple as that. So the first thing to do is because I think the technology is the answer, because humans always make error and technology very rarely makes errors. Okay, so the trick is that when we all make errors, I make heaps of errors when I go flying. Maybe you don't want to know that. But the point is that we console the error, all right? But what we want to know is why did it happen? I'll tell you a story. I was sitting in the office one day. I was a 767 fleet manager, and I had a guy ring me up, and he said, from our navigation section, he says, "Oh, look, you need to know that the runway at Tahiti's closed." And I said, "Oh, why is that?" "Oh, our aeroplane's stuck on the runway." And what had happened was that the guy, I don't know if you've been to Tahiti lately, but you go up there and you're halfway down, there's a sort of a turning bay. And when you get into the turning bay, you line up with a couple of sticks, like that thing in Navy, you line up with these 2 sticks, and then you go down towards that and you see another 2 sticks over here. And when those are lined up, then you turn right. This guy turned left nearly and just stopped in time to get off the runway, but he was too tight to get round the other way. Human error. So, so what actually happened was, for a while there, the runway was closed. This is about 10, 15 years ago now, and the tug came out, put the tow bar on. That's why we have a rear-facing tow bar lug on our nose wheels, $14,000, thank you very much, Boeing. But it means that the tug can get underneath the aeroplane, hook the tow bar on and pull the aeroplane backwards. All right, so the upshot of it is that, so that pulled that out, and what have you. So I rang the pilot up, and I said, "Look, I heard about your problem." His reaction was, "Well, how'd you find out about it?" Well, I said, "Well, mate, when you close the runway, sort of, the balloon goes up." And of course, so I heard about it. And he says, "Oh, well, how can I help?" I said, "I just made an error." I said, because he thought I was going to get a wire brusher. But in actual fact, all I was interested in, I said, "Well, hey, look, to think of it like this, you've got a lot of mate. I know that this is a great guy. He's a very capable pilot. And he just had a brain explosion, just turned left instead of turning right, you know what I mean? Because the terminal was back that way, so sort of mindset was go that way." And so what happened was and the other thing too, he'd come in the other way, and he'd always come in one way, came in the other way, and of course the turning was slightly different. So he said, "Well, you don't want your mates to have the same problem that you've had." Absolutely not. So you need to tell me what's occurred, so therefore I can then fix it for them. So I can actually future-proof the issue for the next guy. And so that's what we do. That's what we do in the aviation system. Now, if I got into a situation where some passenger complained about the fact that he sat on the plane for 15 minutes because he missed a meeting, because he didn't get to the terminal building in time and that sort of thing, so I need to be sued and that sort of thing, so therefore I need the information to come out of the system. In order to do that, we stop that. We don't go there. All right? So we have a system that is open, but by the same token is resistant to the influence of sort of the wider legal system. And the big thing here is to console the human error, coach the at-risk behaviour. So what's my problem at the moment in the people safety area? People running across the road down by the hub. The hub's our head office down there. We've got Fonterra building their building. We've got Barbara Chapman at ASB, tragic just the other day, somebody run over down there. You know, there's a whole lot of traffic issues around that area, and we've got a building across the road from the hub. And what I've got is staff running across the road to get to it, taking the shortcut. Do you know why? Because they've forgotten the consequences of the outcome for the risk that they're taking. Do you see what I mean? And the outcome just recently was very, very tragic for one of Barbara's team. So the at-risk behaviour is to coach. So we coach at-risk behaviour. We do not punish. We do not punish human error, and we do not punish at-risk behaviour. What we will do, however, is get into, when it comes to reckless behaviour, and there's a whole process around this, we actually will deal with it. Punish is probably a pejorative word, but you know, we will take action as a result of that. And I think this is something that the food safety fraternity should pick up on. A just culture. Look at James Reason's model. Have a look in the web, and you'll find it there. The other thing you've got to have is a huge dose of change management process. All right, change management is a hugely risky endeavour. All right, and it's got to be managed. It's got to be managed properly. So what we do is we plan before use with regard to change management, key issue. And then fundamentally, as far as Air New Zealanders are concerned, all this is embedded in our code of conduct. All Air New Zealand staff sign a code of conduct. They refresh it every year. Okay, and it's a document. Everybody has to sign up to it, and this is how we behave. And this is page 1, and there's actually about 5 dot points in there. Operate safely, responsibly and reliably, and there's 5 dot points there, and I'm responsible for the first 4. Slightly perturbing. And the other thing we do is look for mindful leadership. All right, so this is just simply a slide out of our internal training module with regard to safety as being a shared value. So safety is a value, and when people understand what the values of the organisation are, then it drives the culture, and the culture drives the performance. So you can see the face of the organisation there. Now all of this adds up to what is the level of safety? 10 to the power of -9 of a catastrophic failure of the system per flight hour. That's what it is, all right? So it's not absolutely safe. It is not absolutely safe. We work on a risk-based methodology of 10 to the power of -9 of a catastrophic failure of the system of the flight hour. So this evening, when I get on the aeroplane to go to Los Angeles, San Francisco, I don't expect somebody to say, cheers, good luck, hope it goes well. You know what I mean? But in the final analysis, there's a 1 in a billion chance that something could go wrong. That's the reality. You know, that photograph is there, that's the ash cloud from South America that came around the other side. So the trick here is, how do you manage the risk? So, you know, the ash was coming. We could see it coming. I went up to Alaska in 1995 after Ruapehu went up, worked out how we could operate on, around, in, adjacent to volcanic ash, wrote a book about it, stuck it in the, wrapped it up in plastic and stuck it in the bookcase. London popped up. I was in London at the time when the Iceland thing went off. Couldn't, the European Union, there were 300 people on a conference call. It doesn't work, I can tell you that now. They could not get their act together. So as a consequence of that, we just waited until, you know, political pressure, all of us, you know what, nothing changed. Absolutely nothing changed, and all of a sudden it's safe. Think about it. And then, so I got back to New Zealand. The London guy was it was quite interesting. I had to go, it was a bit of a pain really, because I was actually on holiday, and of course, Rob Fife rang up at the time and says, oh, you better go to Hammersmith because the London guy's here, so you're up there, so you're it. So I ended up running the London show for about 3 days, and then I jumped on the aeroplane and got back to New Zealand. So the upshot of it is that the learning from that came down to New Zealand, revised the manual, and then of course the South American ash cloud came around the world, so we said, oh, it's coming, we better work out a risk review. 33 pages, worked out what the critical risks are, what the moderate risks are, worked out what the treatments, the mitigations were, sat down with the regulator, got them in, let's have a work out this, worked in partnership with the regulator, came up with the answer, filed it off, worked out a whole lot of operational mitigation procedures, stuck them on the aeroplane, trained the pilots, talked to the engineers, carried on flying. Next morning, we were flying, the others weren't. It's as simple as that. What's the outcome? $16 million worth of revenue. That's the outcome. And an acceptable level of safety, better than 10 to the power of -9 of a catastrophic failure of the system per flight hour. I'm pleased you know that now. Okay, so how do we test the system to make sure it's working? We just did one the other day. So we have a thing called the big black book. All right, there's a big black book and then there's a couple of little black books. But the big black book defines our emergency management system and the processes for management.
Your attention please. The fire alarms are about to be tested. No action is required. The fire alarms are about to be tested. No action is required. Thank you.
I think we'd all been in trouble if it was a real fire the last time around, wouldn't we? So, obviously it didn't work. So the crisis, emergency and business continuity management system. Do anything. So the upshot of it is that the problem was that the airline's response, so it's not the event, it's the response to the event. That was the problem. And a lot of it came out of this outfit, ValueJet. Low quality, low cost, okay, but not low quality. So ValueJet was an airline out of the southeast of America, flying these aeroplanes, DC-9s. Somebody put a box of chemical oxygen generators. I've got a photograph of one, here it is here. All right, they're in the ceiling above your head. Okay, so they're not actually inherently dangerous. In fact, they're great if you've got no oxygen. Because what actually happens is pull the mask down and the oxygen will flow. So what actually happens there, in that canister, there's not oxygen, there's two chemicals, iron pyrite and Condes crystals. The two mix together, it's an exothermic reaction. What do you get? Oxygen, heat is the other one, okay? And there was a box of these things downstairs, they weren't being stored properly, and one of them went off, they all went off, the wings came off, and the whole thing ended up in a field in the southeast of America, and that's the memorial. Everybody was killed and landed within a space about the size of this room. It's all bad news. Okay, this airline went out of business 6 months later, and they didn't need to. And do you know why? Because they didn't manage their reputation and they didn't manage their share price. And so the whole point of our emergency management system is to actually deal with that issue, not only tactically dealing with the issue on the day. And so how it works is that in Air New Zealand is to not only deal tactically with the issue on the day, but say we've got a business in a week's time, 6 months' time, a year's time, 5 years' time. So it's split into two. There's a senior executive group coalesce in the boardroom, and the group emergency management guys, which I chair, even though I'm part of the executive, I deal with the tactical stuff out at the airport. And we will test, and we will do two things. I look after the tactics of the event on the day. Christopher and the team will make sure that this business is still going at the end of the day, at the end of the week, at the end of the month, at the end of the year. So it's fundamentally, and there's plenty of ways of cutting this. It is not a command. I'm actually running the show. Let's be clear about that. So I deal with the actual process on the day. Chris's job is to ask the right questions, and I may or may not answer them. And this is embedded in our exposition. When you get the fish heads at the top getting involved with the issue at the coalface, you've got a problem, all right? Because they're not thinking strategically. All they're thinking about is tactically, okay? So I want to make that point quite bluntly, but very, very clearly. And we gave some advice to Fonterra on this issue, and they've been taking that advice and have moved ahead quite well with their reaction to their event recently. So exercise, we test the process and the system, we refine our learnings, and we build capability and competency. We test the system regularly. I'll get onto that in a minute. So what do we want to get out of it? Situational awareness. The tunnel comes in, the tunnel vision comes in when you're in a crisis. All right, very hard to see the way forward. Environmental awareness, so I'm not talking about the environment, but the environment that you're in. Your mode changes during the course of an event. So there's this initial event part, and then there's the normal phase. Perpignan, I was in the room for 2 weeks. Basically 2.5 weeks I was in the same room, all right, and you move out into different modes as part of that process. System awareness, and of course time horizon management. So how long do you think it would be that I want to see the first draft of the press release? The balloon goes up, aircraft's, let's say we've had a catastrophic failure of the system, so worse than 10 to the power of -9, so the airplane's gone on the fritz. So when do you think I want to see the first draft of the press release? Well, what's that? 3 minutes, okay? So the guys are working on the first draft at T+3. all right? It's got to be signed off by T+15. 15 minutes is when it goes, all right? But I expect that Christopher and I see it at the same time, and the first draft is already worked up in that sort of time frame. It doesn't have to be accurate. Well, it has to be accurate with respect. Sorry. It's got to be, any media here? There's got to be accurate with respect to the event, all right? It's got to say an event has occurred. You've got to take the people with you. An event has occurred, we are dealing with it, we're underway. Do you see what I mean? And then you come back in and so there's other processes and that sort of thing. So time horizon management is absolutely critical. We do 4 full system exercises a year. We do 2 to 3 desktop exercises a week. So somebody will go down to Nelson and run a desktop exercise with the Nelson Airport guys, okay? Then they'll shoot down to Invercargill and do something the next week. Somebody else is talking to cargo. Etc. We've got 11,500 employees, 6,500 are involved in the delivery of the operation to the business. You know, we do, I don't know if you know, we typically move 39,500 people a day using 600 flights, 105 aircraft in the fleet. You know, moving 350,000 kilograms of bags, 250,000 kilograms of cargo, 25, believe it or not, people still send mail, 25 tonnes of mail. And we burn 3.6 million litres of fuel a day doing it. All right, we're the largest single user of petroleum products in New Zealand on a daily basis. So there's a lot of operational activity that goes on here that can have quite significant consequences if we get it wrong. So what we want to do is make sure we test it. We deal with environment, we deal with system failures. So we did one just last week, nothing to do with aeroplanes. We had 3 IT failures, all right? One of them was an external incursion into the organisation. So we actually dealt with an IT, people getting inside the business and then stealing data. That is a major business event for us, and the emergency management system kicks in. So if you're thinking this is all about planes and operational stuff, think again. Obviously we deal with natural disasters and business continuity events, as I talked about. Okay. What do we want to see? We want to see full participation across the business. We get the media involved and including social media. We liaise with the agencies. We use, we obviously involve, so often we'll have observers. We've had the police observe, we've had the search and rescue guys, the government office of the Prime Minister and Cabinet office come up and that sort of thing. So we bring them inside the business so that we can see what's going on. We obviously talk to the market and the regulator. It's very interesting, about 4 years ago, we were in the middle of an exercise and the stock exchange rang up and says, "Have you had an accident? This exercise is now over." Somehow it had leached out, so there was a protocol breach there. We have injects. We'll actually have, for example, Chris will go off and do a press release and then that'll come up on a screen later on, like CNN. We get down to that, we'll use actors to come in. We have injects from outside, people ringing up saying, "I've seen the plane do this," all that sort of carry on. We'll do a hot debrief and then we'll obviously review the event and then publish the outcomes across the business with respect to the learnings. So what we wanted to get out of it is to implement the learnings, refine our processes, publish our exposition and refine it, confirm the resources, we've got the right level of resources for the job that we're doing, and then we do it all again and again and again. And of course, then as a consequence of the airline industry in Air New Zealand having a way of doing business, then we get involved in other things. And I don't know if you know, but we have 600 people. This is called the Special Assistance Team. So we have 600, many multilingual people within our organisation who are trained. Some of them have blood pathogen, records and that sort of thing, Hep C, A, B, whatever, and they are ready to deploy, all right? And so they will go along. If, say, an aircraft accident, you need somebody with the families and that sort of thing. So Pike River, we dropped people into Pike River and they were there for 3 months. So we had 26 of our staff down there for 3 months, and of course we obviously had quite a bit to do with the Christchurch earthquake. So what are the learnings from this sort of walk through Air New Zealand safety management system and how we do it, and hopefully help you go from good to great? Strong regulator, strong relationship with the regulator is critical. So the idea that the regulator is somebody that you don't want to be a part, to have standing alongside you, is totally wrong. There is an obligation on the regulator, all right? I don't know if there's any regulators in the room. but there's an obligation on the regulator. Is it the front row? Right. This is them up here, is it? Okay. So there's a strong obligation of the regulator to work with the industry, okay, to drive those outcomes. So the idea that we never hear you are the regulated and we are the regulator. That doesn't come out of that doesn't work in the aviation system. Hopefully it won't in yours either. We use risk-based safety management. So absolutely safe doesn't work. Laissez-faire, the other end, 10 to the power of -9 of a catastrophic failure of the system. It's extremely well defined. It's very well articulated in the exposition. It sounds rather balls-achingly, complex and that sort of thing. It isn't. Once it's well done, then people know where to go and how to work it. We have an embedded just culture and we test the system regularly. And hopefully that will result in an outcome that will drive a better food safety management system for New Zealand. Thank you.